Hello and welcome. My name is Vishwanath. In this video, let us try to understand a simple implementation of a distributed computing system where we consider having one client and two file servers. This is implemented in a cloud-based lab. Think of these machines as EC2 instances or VMs or local machines themselves. So the purpose of this implementation is using the client. Uh, we try to establish connections with the file servers and ultimately try and fetch and read the contents of files present on the file servers. Specifically, one of the node will act as a coordinating server. So when the client initially connects with the coordinating server, like the name mentions or like the name means, will coordinate internal connections with the other file server. So when a file is not present on the first file server or the coordinating file server, the same is responsible to look up or establish a connection with the other file server and then ultimately return the contents of the file from the other server to the client. So we have different test cases for this implementation, and all of these will be demonstrated in this video in a detailed manner. First up, let us understand how the client and server programs are implemented. So the programming language used here is Python, and uh, let us get a brief understanding of how the program is structured. We use the inbuilt socket module or function available in Python. These are the configuration constants. So we are currently understanding how the client program is set up. The host here refers to the coordinating server or the primary file server. This is the port on which the server will listen to, and this is the buffer size set. As already mentioned in the introduction part, the purpose or objective of this implementation is the client will try to read or try to fetch contents of a file from the file servers. So therefore, in the client implementation, we try to input the file name from the user and establish a connection with the primary or the coordinating server, which we just discussed. Based on whatever the content received from the primary server, the same will be displayed in the output of the client program. This is a simple implementation of the client side of the implementation. Next up, let us understand how server 1 works, or server 1, in other words, is referred to as the coordinating server. So the coordinating server is responsible to do multiple things. First, accept the connection from the client, look up internally within the local system, also try to get the file from server 2, and then another important task here is to verify if the contents are same. If the contents are same, server 1 is supposed to send a single copy of the data to the client. If it is different, the same has to be sent in different as they are found on the different files. So let us start with the main function where the implementation starts. Um, Initially, we are setting up the server 1 and the host, and so the host here is set as 0.0.0.0 because server 1 also tries to establish connections with server 2. So thereby we are not limiting the host to local host, and thereby allowing connection with server 2 as well. These are the port numbers for the client. So this is the port number that is available for the client connection, and this is the port that is available on the server 2 for connection with server 1. The buffer size remains the same. So coming back to the main function, initially when we start the server 1, we display a message saying that server 1 is listening on the port. So the port here is the port available to the client for connections. And if while the server is up and running, if when a connection request is received, so the handle client function is called. Let us understand what happens in the handle client function. we know that the file name is passed from the client machine or the client implementation. So the same parameter or same is received or same is processed in the handle client. So whatever is received from the client is now initially stored in file name, and file name will be used as parameters for the two functions: get local file, get remote file. Like the function name sounds and should mean, get local file is the function used to search and get the file present on the local system, that is server 1 itself, and get remote file is used to get the file from server 2. Before we understand these functions, let us finish the handle client function so as to see what exactly happens. So if the file is not present on the local system as well as on the remote system, handle client will return a message saying file not found on both servers. So this will be passed from server 1 to client, and then the same will be displayed. Next, the scenario when the file is present on both the local system and the remote system, that is server 1 and server 2. In that case, we carry out an if-else condition. If the file contents is the same, we just send the copy of the local file, or basically we send the contents of one of the file. If the contents is different, what I mean by this is a file with the same name is present on the local system as well as on the remote system, but the contents are different. In that case, we clearly represent server 1 version, the contents of the file present on server 1, server 2 version, contents of the file present on server 2, and the same is uh, sent back to the client. Now we are left with two other scenarios where the file is present only on the local data, that is present only on the local system. In that case, we send back the contents of local system. And the last case remains where the file is not present on the primary system, that is the server 1, but it is present on server 2. In that scenario, we send the contents of the remote file. So that is the handle client. Next up, let us now understand the get local file function, the easier one, where the file name is just used, and then using the default Python modules and functions for file searches, we basically append the file name to the files directory. So both server 1 and server 2 will have a directory called files, and within files, all the sample files which are used for this implementation will be saved. So that is a prerequisite knowledge required to understand. So within the files directory, we append and search for the file name. If the file exists, we open the file and read and return the contents of the file. If not, we return none. That is a simple implementation of local file. In the case of remote file, where we try to get the contents of a remote file, that is file present on server 2, we first implement a try and except construct. Because in the except construct, we take care of a scenario where connection to server 2 fails. In that case, the exception should just produce this diagnostic message saying failed to connect to server 2 and return none. When the connection is successful, so like in this case, we again want to print the diagnostic messages saying that we are attempting to connect to server 2. This is the IP address of server 2. And once it is connected, we display the message saying that connection was successful or it is connected to server 2. Then we are sending the file name to server 2. Based on the implementation in server 2, which we'll look in just a few minutes from now, data is the output, or data is the final return value received from server 2. Based on whatever is sent back from server 2, we will next carry out an if-else condition again. So if data says not found, which means that the file is not present, then we will just print server 2 reports file not found and returns none. If the file is present, that is, if there is some content present in the file, then the same will be returned as it is, return data. So get remote file is the function where we are first setting up a connection with the server 2, and then depending on whether the file is present or not, we we print the respective message and return the respective data. That is either return none in case of file not found and return the data when the file is found. Lastly, let us now look at the server 2. Server 2 is where um, server 2 is where the files are are searched for, and then the contents of the same is sent back to server 1. So here again, the host is set as 0.0.0 because server 2 should let a connection from server 1. Port used for listening here will be 9002. The buffer size remains the same. So in the main function, we start the server 2 and display the message saying server 2 is listening on the port number 9002. And when a connection request is received, so where does the connection come from? It comes from the coordinating server or server 1. It calls the handle request function. So within the handle request function, it is a very simple implementation of basically searching for the file. Exactly what we did in the server 1, that is the local case where the file is simply present on the local system. So basically we accept the connection, store the file name, and then create the file path. Similarly, we just append the file name to the files directory already present, and then search if the file is present. If the file is present, data will save the contents of the file, and then the same will be returned back. If the file is not present, this function will return not found, and ultimately server 2 will return not found to server 1. So with this, we have understood the programming implementations of all the three, that is client, server 1, and server 2. Having said that, now let us jump to the demonstration part. We expect that the demonstration should start from the client where we input the file name, but we know that client will try to establish a connection with server 1 and server 1 will try to establish a connection with server 2. So it is necessary that we first start or execute server 1 and server 2 first, and then to the ultimately the client function. So let us start with the server 2, Python 3 server 2.py. This is the uh, uh, program or implementation of server 2. We see that server 2 is up and running and it's listening on 9002. Let us now jump to server 1 and execute server 1's implementation. So now server 1 is up and running and it is listening on 9001. Ultimately, now let us come to the client machine and let us now run the client implementation. So when we run the client, the simple prompt here is it asks for the file name. So here we will execute different test cases or scenarios. The first one will be a case where the file is present only on server 2. s2.txt is the file that is present on server 2. Let us try to get the contents. So as expected, we see that the message is hi from server 2. Now, to make understanding much more concrete, let us go to server 1 and see what is happening in the background. Server 1 was listening on port number 9001. Because the file is not present on server 1, it attempted to connect to server 2. After establishing connection, it received the message from server 2, and the same was returned back to the client, which we see here. Next up, we implement a case where the file is present only on server 1. Hi from server 1. So in this case, again, an important point to notice is even when the file is present on the primary server, that is the coordinating server, it will still look for the file on server 2, because if it is present, then it will also have to carry out a matching function. In this case, server 2 will say the file is not found. Therefore, the content of the file on server 1 is just uh, is just uh, presented on the output. Next up, um, let us carry out a scenario where a, a file with the same file name is present on both server 1 and server 2. The file is saved as same message.txt. So in this case, the same file, same message.txt is present on both server 1 and server 2, but we see only one output received saying DC project. So this is the scenario where first it will look for the file within server 1. It has found, and it will then connect to server 2. Then it will get the contents from server 2. And then because the matching function in server 1 finds out that the contents of both the files are same, it will return the contents of the local file. That is the file present on server 1. That is what we see here. Next up, we will carry out a scenario, or we'll run a scenario where a file with the same file name is present on both the file servers 1 and 2, but the contents are different. Sample underscore different diff.txt. In this case, you will see that the contents of server 1 is explicitly printed here with the message saying server 1 version, and contents of the file sample.txt, sample.diff.txt from server 2 is explicitly printed with the different message here. So we see both server 1 version and server 2 version, but it is the same file name present on both the files. Now we are just left with the last scenario where we will see how the system behaves when file is not present in either systems. So let me just choose a name like absent.txt, which is absent anyways. So when the file is not present on both the servers, you see a message on the client side saying that file is not found on both the servers. So with this, we have carried out different use cases or test cases uh, of a simple yet concrete demonstration of a distributed system in which we had a single client accessing two um, uh, two file servers and one acting as a coordinated server. Thank you for your time.